Okay, Unit 3, 3.1 is all about transformation. Well, Unit 3 is all about transformations. 3.1 is specifically about translations. So I know I said Unit 3.1, we're going to call this one translations. That way you'll know exactly what video goes with what handout. Alright? Because we're learning about transformations, but there are different kinds of transformations. Today we're learning about translations. Alright? A transformation is an operation that maps an original figure called the pre-image into a new figure called the image. Before, after. Before, after. Get it? On the graph to the left, ABC is your pre-image, right? ABC, triangle ABC. You don't have to put the triangle symbol, but it does help keep things organized. Triangle ABC is the pre-image, it's the before, and triangle A prime, B prime, C prime is the new. It's the image. It's the after, right? This little doohickey is a prime. It's called prime for this purpose. I know. Alright, now a transformation can change the position. It can change the orientation. And it can change the size of a figure. Right? So position, it can move left and right, up and down. Orientation, it can spin. Or size, it can get bigger and smaller. Today, we focus on position. We focus on translation. Alright? The transformation we're working with is considered a rigid motion transformation. And rigid motion means that while you're picking up the shape and moving it, you're not actually changing the size or the angles or any of that yet, right? We're just taking the actual original shape and moving it. But you're not changing the side lengths or the angles. Okay? So, rigid motion is defined as when a transformation preserves, protects, right? Preservatives in your food, protects your food from going bad, preserves the size and shape of a figure. Right? It preserves the size and shape of a figure. So all the corresponding, let's say all the corresponding sides and angles stay the same. From the pre-image to the image, right? Stay the same. We're not actually changing the shape yet. The ones we're working with right now are rigid motion. They don't change the actual shape itself, they just move it around. Right? There are three types of rigid motions that we're going to work with. Translations, rotations, and what's the third one? Reflections. reflections. We're going to reflect it. Translations, rotations, and reflections are all types of transformations that are considered rigid motion because we're not changing the shape itself. All right, we're starting with a translation. A translation is to vertically and or horizontally, and or horizontally slide a figure, right? We're going to slide the figure, slide a figure, right? So slide to the left, slide to the right on the x-axis, or slide up and down on the y-axis, right? So the coordinate notation for that is we start with the original x, y points, our coordinates, right? And for the x value, we're going to add or subtract an h. H is your horizontal, right? H is your horizontal. So you're going to add or subtract your h, because if it's a -7, you're going to subtract h, right? H represents the horizontal shift. The shift on your x-axis, right? That's your left and right. And then plus or minus your k on your y-axis. Your k represents your vertical shift, and that's on your up and down on your y-axis. All right, so you can actually see it here. We shifted 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 down. We just picked up the whole thing. Like we cut it out, we shifted it, and then we put it back down. That's all we did. We didn't change the shape. It still has the same side lengths. It's still identical. We just moved it. It's called translating it. All right, let's do it and see what it looks like. I'll do the odd, you do the even. It says graph and label each figure and its image under the given translation. Identify the coordinates of the image. So it's going to give us the pre-image coordinates, right? So that we can graph it. And then there are two different ways that you can graph the image, the new, the after, right? I'll do it both ways, right? So first, pre-image, right? This is my x, this is my y-axis, just in case I forgot. And coordinates are always x comma y. We walk left and right before we walk up and down. All right, so my q is -6 comma -1. So we're going to go 1, 2, 3, 4, 5, 6. Wait, 6 and down 1. 1, 2, 3, 4, 5, 6 and down 1, and that's my q. My r is left 3, up 1. 1, 2, 3. This is r. S is 1 comma -5, so 1 to the right, down 5. 1, 2, 3, 4, 5. This is my S. My T is left 2, down 7. 1, 2, 3, 4, 5, 6, 7. And that's my T. All right, this is the pre-image. Let me connect it so you can see it. Remember, rigid motion means we're going to pick it up and move it, but we're not going to like change the shape, right? All right, the first way you can do this is it tells you you're going to go 5 to the right on the x-axis, right? So pick a point and move it 5 to the right. 1, 2, 3, 4, 5, and you're going to go up 7. 1, 2, 3, 4, 5, 6, 7 on the y-axis. You can do that for all the points. 5 to the right, 7 up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. All right. And now we have our image moved, translated. It's the same image, we just picked it up and moved it. Right? That's one way you can do it. And then to figure out what your primes are, you would just mark your coordinates. Right? So let's do it. This is my T, and it's 3, 0. And then this is my S, and it's 3, 4, 5, 6, 1, 2. It's 6, 2. Right? This is my T. This is my S. This is my R. This is my Q. So my R is 2, 1, 2, 3, 4, 5, 6, 7, 8. 2 8s. These are my new coordinates for my image, my after. Right? And Q is -1, 1, 2, 3, 4, 5, 6. -1, 6. Right? So that's one way you could have done it. You could have literally counted every single point and moved it. Right 5, up 7. And then wrote down your new coordinates. What if I told you there was an easier way to do it? If this is easier for you, do it this way. All right? But just so you'll know, right? If Q is -6, -1, and we're adding 5 and adding 7, then Q prime is -1, +6. So you just do the math, +5 +7, because it tells you +5 +7, and add that to every point, and then once you have your 4 points, then you go back and graph. If that's easier for you, do it that way. Right? So R would be -3, 1, +5 +7. R prime would be 2 and 8. Right? So whether you move each point and then figure out the coordinates, or if you figure out the coordinates and then graph each point, either way works. Do what works for you. Okay? Do what works for you. All right, let's do number 3. Look at number 4. It's telling you on the x-axis to go left 7. On the y-axis, you're going to stay the same. Think about that. Think about that. Is it going to be easier to draw them and figure out your coordinates, or is it going to be easier to figure out your coordinates and then draw them? Right? This time, let's draw our original. All right, J is -4, 7. -4, 1, 2, 3, 4, 5, 6, 7. It's a rhombus. Let's see what a rhombus looks like. 0, 8 for K. -1, 4 for L. And -5, 3 for M. It looks like it's a weird shaped square, sort of, almost. Hey, a rhombus. Now you know what a rhombus looks like. All right, now instead of counting each point, I'm going to do it mathematically. All right, so it's +2 - 2. So -4 + 2 is -2. 7 - 2 is 5. Okay, 0 plus 2 is 2. 8 minus 2 is 6. Uh-oh, this one looks like it's faster. L is negative 2 plus, or negative 1 plus 2, which is 1. And 4 minus 2, which is 2. Be careful with your negatives. This is why I needed you to be able to add and subtract with positive and negative numbers. Negative 5 plus 2 is a negative 3. 3 minus 2 is 1. That was a lot faster in my opinion. Right, now that you have the coordinates, just graph it. Negative 2, 5. That's your J. K to J prime. Right, J prime, so that I know it's your image and pre-image. 2, 6. And that's your K prime. 1, 2. And that's your L prime. Negative 3, 1. That's your M prime. Same shape. We just picked it up and we moved it 2 to the right and 2 down. That's it. This is your pre-image, right? JKLM. And this is your image, your after, because it has J prime, K prime, L prime, M prime. That's how you know it's your after. All right, now vectors. You might have seen vectors before because we use them in rise and run and slope, right? It's how we figure out slope in some cases. Vectors is just another word for this little shape that we draw underneath, right? It's the directions. Vector is your directions, right? Vectors are defined as a quantity with both direction and magnitude or size. A quantity with both direction and magnitude or size. All right? A vector is represented in the coordinate plane by an arrow drawn from an initial point. This is my initial point. Initial point to an end point. This is my end point. End point or terminal point. Some people might say terminal. Terminal, it means ending, right? Your end point or your terminal point. Initial point was P, my terminal point was Q. All right. The vector is denoted as, look at it. Look at it. It's a ray. P to Q. Initial point, terminal point. It's written the same as a ray, y'all. You just call it vector PQ. What does that mean? It means a vector is a ray, y'all. Vector, vector. Okay. The component form of a vector is written as PQ, vector PQ, right? And then you put little arrows on it. And then you put your A and your B, right? So what's your A and your B? I don't know. So So if I wanted to put this in component form, right, my vectors for J, K, L, and M would be 2 and negative 2. And you put it in the arrows just to remind yourself that it's a vector. Arrows like rays, right? A, B. All right, A is your horizontal component, it's your change in X, and B is your vertical component, your change in Y. So on this one, the component form of the vector to the right is, how many did we go right? 1, 2, 3, 4. And how many did we go up? 1, 2, 3, 4, 5, 6, 7. So we have to write this vector PQ, and it's 4, because the X comes first, comma 7. So if I wanted to tell people how to move this, it went 4 up, it made a triangle. So the component form of the vector is vector PQ is positive 4 comma positive 7, because it went 4 to the right, 7 up. All right, let's look at them. Name each vector, then write the vector in component form. So first we have to name it. We name it initial point, end point with a ray on top. Initial point, end point with a ray on top. And then we're going to give the component in vector form, right? So I go how many to the right or left? I go 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, and 1, 2, 3 up. That's it. That's all you have to do. All right, first name it. Look carefully. The initial point, the end point, they're not always where you think they are. The one with the arrow on it is your terminal point, your end point, right? So initial point, S, terminal R, put your ray on top, equals, put your little vector symbols. All right, initial point on the x-axis, I had to go left 1, 2, I had to go left 2, so it's a negative 2. And I had to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went down 11, so it's a negative 11. So, if you were naming this one, what would you name it? Which one is your initial point? M. What is your end point or your terminal point? N. Don't forget the ray on top so we know it's a vector. Right? Does it go left or right? It doesn't. That means 0. It does not go left or right on the x-axis. It goes up 1, 2, 3, 4, 5, 6. Positive 6. That's it. That's it, y'all. Alright, translating with vectors. How is translating with vectors different from translating with this information? It's not. It's not. It's the same thing. It's the same thing. Right? So, instead of writing x minus 1, y minus 5, they wrote this. It's the same thing. It's the same thing. So you can do the same thing. You can draw your pre-image and then move the whole shape and find your coordinates for your image, or you can just do math. I know, math. All right, so S is -1 plus or -4 plus a -1. Right? A -4 plus a -1 is -5. Right? -5. 2 minus 5 is -3. 5 minus 1 is 4. -1 minus a -5, or plus a -5. You're combining -1 and -5. It becomes -6. -2 plus a -1 is -3. -2 plus a -5 is -7. All right? Do it in 2 different colors if it helps you. Right? Put your pre-image, -4, 2, S. It tells you it's a triangle. It's only going to have 3 coordinates, 3 vertices. T is 5, -1. And U is -2, -2. Told you, triangle. Now let's do the new one in the color I did your prime, right? S prime is -5, -3. 1, 2, 3, 4, 5. 1, 2, 3. And that's S. T prime is 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is S prime. This is T prime. U prime, -3, -7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. U prime. I didn't change the actual shape. I didn't change its size. This is a rigid motion transformation. The shape itself is solid, rigid. I can pick it up. I can drag it left and right, up and down. That's translation. This time we're going to do a rectangle. Let's go ahead and draw our first shape so we know what we're looking at. L is -8, -5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And this is L. M is -3, 0. M. N is 0, -3. N. And P is -5, 8. -8. -5, -8. -5, -8. And this is P. And this is our pre-image. Right? They're both positive. So we're going right 3, up 7. Do you want to do this one like we did the other one, counting off each point and then figuring out the coordinates? All right, M. We're going to go right 3, up 7. Right 3, up 7. So this is now M prime. Right 3. 1, 2, 3, 4, 5, 6, 7. Up 7. N prime. Right 3. 1, 2, 3, 4, 5, 6, 7. P prime. Right 3. Up 7. L prime. Now let's figure out the coordinates. L is first. Let's do 1, 2, 3, 4, 5. I left 5. 1, 2, 3, 4, 5. I went left 5, so it's -5. And I went up 2, +2. All right, let's do M. I didn't go left or right, so my X is 0. And I went up 7. +7. And I went 3 to the right, and 4 up. And then P, I went 2 left, so -2, and I went 1 down, so -1. So whether you do it by the shape to find the coordinates, or you find the coordinates to find the shape, whichever works for you, as long as you show how you did it. Either way is fine with me. All right, last, describe the translation that maps each preimage to its image, first in coordinate notation, and B as a vector in component form. All right, so first, what do we have? EFD, EDF, DEF, DEF. We have triangle, DEF, right? And what did we do to it to go from original to after, before, after, pre-image, image? What did we do? You just pick a letter. It doesn't matter which letter. Let's do F. How did I get from here to here? This is my initial point. This is my end point, my terminal point. All right, so I went 1, 2, 3, 4, 5, 6, 7. So I added 7 to my X. And 1, 2, 3, 4, I added 4 to my Y. So that's what it looks like in coordinate notation. Now, what about in component form, right? Remember, it's the same exact information. The only difference is, instead of writing x plus 7, comma, y plus 4, right, we're going to put the little doohickeys, the little arrows, because it's array, right? And we're going to put 7, comma, 4. That's it. All done. You've translated shapes. Congratulations. Welcome to Unit 3. You do the evens.